Hi, welcome to Unit 4, Day 6, Ionic Compounds, their chemical formulas. This is Part 1, the basics. So, in Week 2 of Unit 4, we're going to learn about how molecules are represented. And there are 4 ways to represent or show or depict molecules. And these 4 ways are listed here. So let's begin with the chemical name. So something like calcium fluoride is a chemical name. It names the chemical, and if you know the naming rules, you can determine what the chemical is. The next way to depict or represent a molecule is through the chemical formula. So CaF2 is the chemical formula, and there's a lot of information you get from this chemical formula. One, you can tell what type of atoms it's made of. So here we know it's made of metals and nonmetals. And it also shows you the ratio of atoms. So we know that this compound is made up of 1 calcium and 2 fluorines. The next representation is a structural formula. And for ionic compounds, the main structural formula that you will see is what's called a Lewis dot structure. And as you can see from the Lewis dot structure, it shows you the atoms. It shows you have 1 calcium and 2 fluorines. It also shows you the charges. Calcium has a 2+ charge and fluorine has a -1 charge. And it shows you where some of the valence electrons are. So you notice how the fluorine has an octet, 8 electrons surrounding it, each fluorine does. The last representation is our models. And these 2 models here are the particle diagram and the crystal lattice. And we've kind of seen this before as well. These are also very useful. What we're going to focus on in this lesson, Day 6, is the chemical formula of ionic compounds. As an extension activity, you can learn how to draw Lewis dot structures of ionic compounds, but our focus is the chemical formula. Alright, so this is the crux of this lesson. The most important thing you need to know about chemical formulas for ionic compounds is the sum of the ionic charge must equal 0, okay? So when you add up all the charges, they have to equal 0. So what do I mean by that? If we look at our calcium fluoride example here, and here we have the particle diagram, notice that the fluorines each have a -1 charge and the calcium has a +2 charge. If you add up all of those charges, -1, add it to the +2, add it to the -1, the overall charge is 0. And that's super important for an ionic compound. If the overall charge does not equal 0, there's something wrong with your formula, or it's not an ionic compound. So what are ionic compounds again? Remember, they're made up of metals, which are have a positive charge. They're called cations, metal cations, and non-metal anions. And here are some examples, and we looked at properties last week of ionic compounds. Now, we also looked at last week how the ionic bond is formed, and it's formed through the transfer of electrons. So let's take a look at that more closely. So the first thing is the metal will lose or give its all of its valence electrons, the outer shell electrons, to the non-metal. And that way it can get an octet. So if it loses all of its electrons, it'll get an octet, and then the fluorine will get an octet by gaining that electron. And remember, an octet means 8 in the outer shell. Now, when that happens, because the metal has lost an electron, it becomes positively charged, and the non-metal, since it's gained an electron, becomes negatively charged. Remember, losing or gaining electrons sort of do the opposite to charges. If you lose an electron, you become positive, and if you gain an electron, you become negative. So because the metal is positively charged and the non-metal is negatively charged, and opposites attract according to rules of physics, that's what forms the ionic bond, that electrostatic is called electrostatic attraction between the positive cation and the negative anion. And then we also looked at last week that a bunch of those cations and anions will get together and form a lattice. So it's not just a sodium and fluorine atom that make up sodium fluoride, it's a bunch of them that make up this lattice. Alright, let's enter our first CFU. True or false? Metals typically have a negative common ionic charge and thus are anions. Pause the video now. When you press play again, the answer will be revealed. Great, the answer is false. Metals typically have a positive common ionic charge and are called cations. So positive charge is the cation. And you can sort of see that here in the periodic table. The blue section represents our metals, and you notice where the metals are, they are in groups that have positive ionic charges. Okay, so just sort of a reminder here about the common ionic charges. Each group has a different ionic charge. Groups 1 and 2 have a +1 and +2 charge respectively. And then 13 through 18 go from +3 to 0. The transition metals, which are in the middle here, they have variable charges, so those charges can vary. Now, knowing the ionic charges or being able to use this table for the ionic charges will be super important here. So if you need to pause the video to study this, that's a good idea. Okay, so what's the aim of this video? Our aim of this lesson is to sort of be able to check a chemical formula of ionic compound to see if it's correct or not. So like if you were given this formula Al2F3, could you determine if it's correct? So how do we do that? The way that we figure out if the formula is correct is we have to keep in mind that the sum of the ionic charges must equal 0. So let's say we wanted to check the chemical formula for NaCl. How would we go about doing that? First thing is we're going to find the elements or the atoms in the periodic table. So this is made up of sodium and chlorine. So I find sodium. Sodium is in group 1. And I'm going to use where it's located to determine its common ionic charge. So if it's in group 1, it's going to have a +1 charge. So I listed that above it. Now I'll do the same thing for chlorine. Chlorine is over here in group 17. It has a -1 common charge, and I know that because group 17 has a -1, so I list it over here. So in order for this formula to be correct, when I add up these two charges, it must equal 0. So does that happen? Yes, it does. If you add +1 and -1 together, it equals 0. And so since the sum of the charges equals 0, the formula is correct. All right, so what about this example? Is the chemical formula for calcium oxide, CaO, correct? Why don't you pause the video now, and when you press play again, the answer will be revealed. Here are some reminders to sort of help you out with getting started. Okay, so let's go through the answer here. The first thing is to find calcium and oxygen in the periodic table, and we've done that. So calcium is in group 2, it has a +2 charge. Oxygen is in group 16, it has a -2 charge. All right, so now that we've figured that out, the next thing was we need to add up their common ionic charges and see if it equals 0. If it does, it's the correct formula, and if it doesn't, then it's incorrect. So when I add up +2 and -2, I do get 0, so that means that this formula is correct. The correct formula, chemical formula for calcium oxide, if you have a calcium and oxygen together in an ionic compound, would be CaO. That means you need one of each of them in order for the overall charge to be 0. All right, how about this example? So pause the video now, try it for sodium oxide. I'll help you out by locating where they are in the periodic table. And when you press play again, the answer will be revealed. All right, so sodium is in group 1, has a +1 charge. Oxygen is in group 16, has a -2 charge. So I'm checking to see if this is the correct formula, and I do that by adding up the charges together. But when I add up the charges together in this case, +1 and -2, they don't add up to 0. So that means that this formula is incorrect, right? Because remember, in order for it to be correct, the overall charge must be 0. So since that's not the case, the question then becomes, well, how can we get the sum of the charges to be 0? How can we correct this formula, right? And what you may notice is, in order for the charges to cancel or balance out, you would need a total of 2 sodiums. So if you have 2 NAs or 2 sodiums, then that should balance out the -2 and give you your overall charge of 0. So how would we tackle something if we had a chemical formula like this, Na2O? What would we do then with that subscript? All right, so now we're sort of working backwards. So the subscript is that small number. What that tells you in this case is that you have 2 sodium atoms, right? And in order to get the overall charge, what you're going to have to do is you can either write out the +1 sign twice since you have 2 sodium atoms, so each one has a +1 and +1. So you add those 2 together and then add from the oxygen. Or the simpler thing to do is to just multiply the subscript with the charge. So we would do 2, that subscript for sodium, times its charge +1. And when you do that, 2 times +1 is 2. And then you can add it to the charge of the oxygen, -2, and that gives you an overall charge of 0. And so if we look at this formula, we can tell that it's correct because the overall charge is 0. So the key thing to know is when you have a subscript, make sure that you multiply the subscript with the charge of that element or atom. Let's see if you can try that out. We'll do one more example and then we'll have you try it. So here we have Al2O3. We want to check this chemical formula. That's, by the way, sorry, I should say aluminum, not sodium oxide, aluminum oxide. And I find them in the periodic table. Oxygen I've already found has a -2 common charge, and aluminum has a +3 common charge. It's in group 13. Okay, so we're going to add the charges. But in this case, since we have subscripts, we're going to make sure we multiply the subscripts to the charges. So I'm going to take the subscript of aluminum, 2 times its charge +3. And then I'll do the same for oxygen, 3 times its charge -2. When I do that, 2 times +3 is 6, and 3 times -2 is -6. Once I've multiplied the subscripts and the charges, I can add those together and see if they give me 0. And in this case, it does. So that means that the formula is correct. Okay. All right, I want you to try it now with aluminum bromide. So here's some reminders. You can pause the video, and when you press play again, oops, the answer will be revealed. Okay, so the answer here is this formula is incorrect, and that's because when you look at the formula, aluminum has a +3 charge, bromine has a -1 charge. If you were to multiply the subscript of bromine with its charge, -1, it'll give you a -2. The aluminum is just +3. If you combine those two together, you get a +1, not a 0. So the overall charge is not 0, it's +1. So this is an incorrect formula. Okay, so if that's the incorrect formula, what's the correct formula for aluminum bromide? So why don't you pause this video now and see if you can sort of figure it out. Remember, you want the overall charge to be 0. So how many bromines or how many aluminums do you need to get the overall charge to be 0? Okay, so the answer for that is D. You would need 3 bromines to get the overall charge to be 0. Now, I just want to point out that letter C was a sort of a trick answer. And the reason why it's a trick answer is because if you were to multiply the charges and the subscripts together and add them together, as we've seen before, the overall charge would be 0. So aluminum has a +3 charge. 2 times +3 will be +6. Bromine has a -1 charge. -1 times 6 will be -6. So the +6 and the -6, if you add them together, will be 0. But the problem with this is that the formula is incorrect because in order for the formula to be correct, the subscripts must be in the smallest whole number ratios. That's what's called the empirical formula, all right? Since 2 and 6 can both be divided by 2, they have a least common factor of 2. These are not the smallest number possible. The smallest number possible would be choice D. So this is sort of a trick, but also meant to help you learn something new. All right, that's it for part 1. Next part is part 2.